All right, our last B level video. So we are going to find the volume and then use a rate. You are using a funnel shown, so right here, to measure the coarseness of a particular type of sand. It takes 2.8 seconds for the sand to empty out of the funnel. Find the flow rate in milliliters per second. So even though, yes, this has an opening at the bottom, we are just going to use our regular cone formula. We're not going to worry about the little bit of difference there at the end. And so we're going to find how many milliliters of sand are in that cone when it's full. So cone formula, we've got volume equals 1/3 pi r squared times height. So we've got the radius is 4 and the height is 6. So 4 squared times height is 6. So we have 100.5 centimeters cubed, because these are both centimeters. And then we've got this note, a centimeter cubed is the same thing as a milliliter, which is what they want our answer to be in, milliliters per second. So if we've got 100.5 milliliters and it takes 2.8 seconds to empty, we just divide those two numbers, and that's going to give us how many milliliters per second the flow rate is. So 100.5 divided by 2.8, we get 35.9 milliliters per second. Okay, so looking at some golf balls now. So a standard golf ball has a diameter of 1.6. So remember, diameter is all the way across, 1.68. Golf balls are often sold in a box of 4. Assume the balls are packed tightly enough so they touch on all sides and the bases, so that like all 4 sides of the box are touching 4 points on the sphere. So what is the volume of the box? So if we kind of think of that box over there, I'm going to draw it long here. So the square on the end is going to have the same sides as the diameter of the golf ball. So like the height is going to be 1.68, the base is going to be 1.68. The length, though, that's going to be 4 golf balls, 4 times 1.68, which equals 6.72. So to find the volume, I just need to multiply the length times the width times the height. So 1.68 times another 1.68 times the long side, the 6.72. We multiply those all together and we get 19 inches cubed. Sorry, this is kind of getting squished here. 19. What is the volume of one golf ball? Well, we're just going to do our sphere volume formula. So 4/3 pi r cubed. Just plug that in. So radius is not 1.68. Radius is half of that. Radius is 8.4. So I got that just by dividing the diameter by 2. So 4/3 times pi times 0.84 cubed, and we get 2.5 inches cubed. What is the volume of all 4 golf balls? Well, we just take that times the 4 golf balls, and we get 10 inches cubed. All right, so what is the amount of volume inside the box not taken up by golf balls? Well, we said the volume of the box was 19. The volume of the 4 golf balls is only 10. So 19 minus 10, there are 9 cubic inches that are just empty space between and around the balls. All right, last problem here. You are going to make push pins in a 3D printer. The plastic part will be a half sphere on top of a cylinder. So we've seen shapes like this before. So if we have a cylinder, and then we are going to put a half sphere, a half ball on top of it. The radius and the height of the cylinder will be 9.3 millimeters. Find the volume for the material required for one pushpin. So let's do the two parts separate here. Let's do our cylinder, and then we'll do the half sphere. So cylinder is pi r squared times height. So pi times the radius squared. And then it says the height is the same as the radius, so I'm going to do another 9.3. So 2526.96. The half sphere, I'm going to have to do 1/2 of the sphere formula. So 1/2 times 4/3 times pi r cubed. So the radius is that 9.3. So you can multiply these in your calculator. 1 divided by 2 times 4 divided by 3. You could also do 1/2 as a decimal, 0.5. Either way, if you type it in correctly, we should get 1684.64. So the total volume is when we add these together. So add our 2526 and our 1684, and we get 4211.6. And these are all millimeters cubed. All right, filament is a plastic, so it's kind of like a plastic string. So it's a really, really, really long cylinder. So it's a circle on the end, but it's really long like a string would be. So they tell us the diameter of the plastic, of the filament, is 1.75 millimeters. Well, for our formula, we're going to need radius. So I'm going to divide the diameter by 2 and get the radius is 0.875 millimeters. And I'm not going to round that. I'll probably end up rounding at the end, but for now I'm just going to leave that. The height of our cylinder, because like I said, this is like one long cylinder. The height, I want it to be in millimeters because that's what our radius is in. So 300 meters times 1,000 means we have 300,000 millimeters for our height. So now just our cylinder formula, pi times radius squared times height. And we get a pretty big number here, 4.56 millimeters cubed. All right, so how many push pins can we make from one spool of filament? So we know one push pin needs our first answer, the 4,211, and one spool of filament is our second answer. So to get how many we're going to be able to make, we just divide. So divide those two numbers and we get 171.3 push pins. But because we can't have 1/3 of a push pin, I'm just going to round that to a whole number. All right.